In the previous video, we talked about number systems. So we talked about natural numbers, whole numbers, integers, and rational numbers. We learned that there are infinitely many rational numbers. In this video, we are going to discuss irrational numbers. So you know that rational numbers are numbers that can be written in the form p by q, where p and q are integers and q is not equal to 0. Irrational numbers are just the opposite. So the definition of an irrational number is a number s is called irrational if it cannot be written in the form p by q, where p and q are integers and q not equal to 0. Let's look at a few examples of irrational numbers. Root 2, root 3, root 5 and so on are irrational numbers, and some other irrational numbers are numbers like pi. Just as there are infinitely many rational numbers, there are also infinitely many irrational numbers. If you combine rational numbers and irrational numbers, you get a new number system called real numbers. So real numbers is the collection of rational numbers and irrational numbers. If you consider all the rational numbers plus all the irrational numbers, you will see that it covers every point on the number line. In other words, you can say that every real number is represented by a unique point on the number line, and every point on the number line represents a unique real number. So the familiar number line is also called real number line. Now let's look at how we can geometrically plot irrational numbers on the number line. For this, we make use of the familiar Pythagoras Theorem. For example, let's learn how to plot root 2 on the number line. You know from Pythagoras Theorem that if you draw a right-angled triangle with these two sides equal to 1 unit, the hypotenuse will be equal to root of 1 squared plus 1 squared, which is equal to root 2. Now let's see how to plot this on the number line. So to plot root 2 on the number line, draw the number line first, mark 0 and 1, and you will have negative numbers on the other side. From the point 1, draw a perpendicular upwards, and this perpendicular should measure 1 unit. Now if you join this line, let's call this point O and this point A. You have just seen that OA will be equal to root of 1 squared plus 1 squared, which is root 2. So we have the distance root 2 here. So OA is equal to root 2. Now we just need to transfer this distance OA onto the number line. So you can just keep a compass with the center at O and radius equal to OA, and just draw this arc which touches the number line at some point, say P. So OA will be equal to OP, which is equal to root 2. So that's how you find the point P, which is equal to root 2. You can extend this construction to find other irrational numbers, to plot other irrational numbers on the number line. For example, if you want to plot root 3, first start with 0, draw a perpendicular at 1 equal to 1 unit, and we are first plotting root 2. So this distance is going to be root 2, and if you draw one more perpendicular at this point, so this is a perpendicular line and this is 1 unit. So let's call this A and this is B. AB is perpendicular to OA and AB is equal to 1 unit. Now if you use the Pythagoras theorem in triangle OAB, you can see that OB is the hypotenuse. So OB squared is equal to OA squared plus AB squared. OA squared is root 2 squared, which is 2, and AB squared is 1. So we can write OB squared is equal to 3, or OB is equal to root 3. So the distance OB is equal to root 3. Now you just have to transfer this distance to the horizontal line by using a compass. So just draw an arc like this with center O and radius OB, and this point P is going to be root 3. So the distance OP is going to be root 3. Similarly, you can go on constructing more and more triangles and plot other irrational numbers on the number line. There is a small side note here. When you write root 2 or root 3, what we mean by this square root sign is the positive square root. So that's the convention we use. For example, if you write root 4, you know that you can get 4 if you square 2 or minus 2. Or you can write 2 squared is equal to 4 and minus 2 squared is also equal to 4. But when you write root 4, it always means plus 2. So the root sign always refers to the positive square root. In the next video, we are going to look at decimal expansions of rational and irrational numbers. Thanks a lot for watching.